Now we have to prove that those 5 formulas are satisfiable. In the previous modules, we learned that this can be solved by using a truth table. However, in this case, using a truth table would be very, very inconvenient, since in those 5 formulas, we have 5 Boolean variables, P, Q, R, S, and T. This means that we should generate 2 to the power of 5, that is 32 interpretations inside the truth table. So the truth table would have 32 rows, and in each of those rows, we should evaluate all those 5 formulas. So this would be a very huge table. It would be very inconvenient to use. Therefore, now I'm going to show you another approach, a more intuitive approach. And let's see. So again, what do we have to prove? We have to prove that those 5 formulas are satisfiable. What does it mean? I have to find at least one interpretation which makes all those 5 formulas true at the same time. And this means that I need to find out what values, what 0 or 1 values to assign to the particular variables, what 0 or 1 value to assign to P, what 0 and 1 value assigned to Q, and so on, to make all those 5 formulas true at the same time. Okay, so let's try to find this out. So first of all, it's quite intuitive to start with the easiest formula, not P. Since now we are proving satisfiability, we are proving that all those formulas can be true or 1 at the same time. We know that this formula must be 1, of course. And of course, it implies that then P must be false. So 0 as a value must be assigned to P. This is a fact. And this is what we are going to use later on. Okay, so how to continue? Well, P appears in 2 other formulas. And let's take the shorter one. R implies P. Since we are proving satisfiability, again, this formula must be 1. Each of those formulas must be 1 at the same time. Okay. So we just proved that P must be false. And therefore, since this implication R implies P must be 1, there is no other way just to assign 0 to R. This is the only way to make this implication 1. So this implies that R as a variable must be false, right? Let me just highlight this fact. Okay, well, we can see there is a very similar formula to the previous one, the third formula, Q implies R. So this is also an implication, which again must be 1. And long story short, similar to the previous formula, now we can prove that Q must be false as well. Okay, so there are 2 formulas left. Let's pick the shorter one, especially because it contains Q. So the shorter one is Q or S. And since we know that Q must be 0, there is no other way to make this disjunction true than to set S to 1, right? So yeah, 1 should be assigned to S. Yeah, so we are almost done. We assigned 0 to P, Q, and R, and we assign 1 to S. There is one more variable which is not assigned yet, and this is part of the 5th formula. So let's analyze the 5th formula. S implies T implies P. Of course, this formula must be true as well. And now let's see, what do we know already? Well, we know that S must be 1 and also P must be false. So since the main operator is an implication, and I know that the left-hand side S is 1, there is no other way to make this entire formula 1 than assigning 1 to the right-hand side as well. And how to make T implies P1? Well, since P is 0, there is no other way than to set T 0. Exactly. So we just derive that T must be 0. And now we are done. So we found an interpretation which assigns 0 to P, Q, R, and T, and 1 to S. And since we found such an interpretation, we prove that this formula set is satisfiable.